In the part 1 of this lecture, we people were discussing about abstraction. See, as I have told you, abstraction is something that we are making use of without going into details. Suppose we are making use of the functions of a class without bothering about the inner coding, the details of the inner coding that has been put into that class. For example, see, first I am going to tell you, in object-oriented programming, there are two types of, at any point of time, there can be two types of developers, class creators and second class users. Class creators and class users. As far as class creators is concerned, class creators are the programmers who have developed a particular class, and class users are the programmers who are using the classes developed by the class creators. At any given point of time, if you are a software developer, at any point of time, either you can be working as a class creator or you can be working as a class user. Now see, the class users, they can use the classes of the class creators without knowing about the details of the coding that has been put into these classes. This is called abstraction. This is called abstraction. I will give you a very simple example. Suppose I happen to write down a software. At the time of writing the software, suppose I need to work with some mathematical functions, and say I am not well versed in mathematics. So all the functions which are to be performed related with mathematical calculations, what I will do is I will hire a programmer, or I will request to some other programmer to write down those functions for me. That particular programmer will develop the class for me, and that person will be called the class creator. What I will do is I will make use of that class in my software. I would be simply supposed to instantiate the objects of the class, and I would be calling the functions which are required by me, by my software. Now what will happen is, if suppose I am calling a function which is supposed to calculate the standard deviation of a given set of numbers. Now what will happen is, when I will call that function, the standard deviation will be calculated and that will be returned back. But I will not be interested, or I am not aware of the inner coding that has gone into calculating the standard deviation. This is called abstraction, right? So this is called abstraction. Now we come to another very important feature of object-oriented programming, and that is polymorphism. As you people know, polymorphism, poly means many, morphs means forms, shapes. When one particular thing has many shapes, many forms, and it can be used in different contexts, one particular thing can be used in different contexts, that will be called polymorphism, right? So exactly how polymorphism works exactly in object-oriented programming languages like C++ is, I will give you an example. See, suppose I write 10 plus 15. Here plus operator is being used to add two integer values, right? Now here I am adding two real numbers, that is I am adding two float values, 6.99 plus 7.96. The same plus operator is being used for adding two integer values, same plus operator is being used for adding two float values. Similarly, suppose I happen to write Mahajan plus computers. String concatenation is taking place. So here Mahajan string will be concatenated with computers. Again, plus operator is same, plus operator is same, but this time over it is being used to concatenate two strings, to join two strings. So plus is one thing, is one operator which is being used to perform different types of calculations. That means it is being used for adding the values belonging to the different data types. This is particularly in C++, this is called operator overloading. Operator overloading is also a kind of polymorphism. Similarly, in later sections we will be discussing about function overloading. that too is called polymorphism, rather that is called compile time polymorphism. But again we come to this point, polymorphism. Now again I will repeat it. Polymorphism is the capability of any programming language, object-oriented programming language, to use operators or methods in different contexts. Now see, another definition of polymorphism would be, that will go like this. Polymorphism is the ability to call different functions by using only one function call. Right? So I will give you an example. Suppose we have got different classes. Suppose there is a class called doctor's class. In doctor's class, I have got a function. Suppose that is display. The same function display is also in the engineer's class. The same function is also in the, suppose, scientist class. What I can do is, I can take one particular pointer to object, and this pointer to object can call, at one point of time it can call the member function of the doctor's class display. At any other point of time it can call the display member function of the class engineer. The same call will call the display function of the scientist class. So same call is being used to call the functions belonging to the different classes. This is called polymorphism. How polymorphism is implemented, that is through virtual functions in C++, that we will be discussing in next lectures. So right? So look for other video lectures related with C++ programming. Thank you.